Hello, grade 12s. Welcome back to the channel, Science Therapy. In today's lesson, we're going to be looking at quadratic sequence. And without any further ado, let's look at this question that we have here. Okay, so it says, given the quadratic sequence 5, 7, 13, 23, and then question number 1 says, write down the next two terms. But before we do that, let's discuss this. We know that if we have a quadratic sequence, it will have the first difference and the second difference. The first difference of a quadratic sequence is actually the arithmetic pattern, and the second difference represents the common difference of that arithmetic pattern. Let's show that. So we have this pattern here, which is the quadratic pattern 5, 7, 13, and 23. If we want the difference between the first two terms, we just say 7 minus 5, that's 2. And then we say 13 minus 7, that's 6. We say 23 minus 13, that's 10. So we have our first difference. Look at this first difference. This is actually an arithmetic pattern. So there is a relationship between a quadratic pattern and an arithmetic pattern. Then let's look at this at the second difference here. We're going to say 6 minus 2, that gives us 4, and then 10 minus 6, that also gives us 4. Right. So we have a constant second difference, right? Then to write down the next two terms, this is what we need to do. We know that here we'll always have a consistent second difference, so we can say add 4 to this 10, that's going to give us 14, right? So we have 23 plus 14, that's going to give us the fifth term of this pattern. So 23 plus 14 is equals to 37. But once again, a consistent second difference 4, and then we take that 14 plus 4, that's going to give us 18. Now we need to say this 37 plus 18. Then we get the sixth term. So 37 plus 18 is equals to 55. And just like that, you have the next two terms. So the next two terms are 37 and 55. Right. Then number 2 says calculate the nth term of the quadratic sequence. Now that you have all this, we know that to calculate the nth term of the quadratic sequence, we need to equate the second difference here to 2a, and then equate the first difference to 3a plus b, and then the term of the quadratic sequence to a plus b plus c. Now we're going to choose this first branch here in order to do all that, right? So take 4 equated to 2a. Let's begin. This is 2a is equals to 4. Then at this point, we need to divide both sides by 2. So we have a is equals to 2. Right. Then when we have that, let's take the a here and substitute it right into this equation there. So that is 3. And then this is a2 plus b is equals to 2, right? So we are equating it to this value here. Then what is 3 times 2? That's 6. And then let's just transpose it over to that side. That would be 2 minus 6. So our b would be equals to negative 4. But now we need to find the value of c by substituting the value of a and b here. So that's negative 2. That's positive 2. That's positive 2 plus negative 4 plus c is equals to 5, right? So we have 2 minus 4, that's negative 2, and then this is going to end up as 5 plus 2. So we have the 2 minus 4 is negative 2, then if we transpose the negative 2 to that side, it's positive 2. So hope you understand that. Then c is equals to 7. So now we have our values for a, b, and c. That means we can write our our nth term for the quadratic sequence in this form: an squared plus bn plus c. Remember, it's in quadratic format. Then what is our a? Our a is 2, so this would be 2n squared, and then your b is negative 4, so that's negative 4n, and then your value for c is 7, right? So this is your nth term, or your general formula for this quadratic sequence, right? Now, let's proceed to number 3. It says determine T10 of the above sequence. So in order to determine that, we're going to go ahead and write the quadratic pattern, the general formula for the quadratic pattern, then that's 2n squared minus 4n plus c, right? So what are they looking for? They're looking for T10. So basically what you just do here is say T10, and then where there's n, you just substitute that 10. That is 2, and then in bracket 10 square minus 4, and then here you put your 10, and then plus 7, right? Then let's punch that in our calculator. That's 2 bracket 10 square minus 4 bracket 10, and then plus 7, right? So that is going to give us 134, right? So that's your value for term number 10, right? Then number 4 says which term in the sequence is equals to 55. Now, how do we do this one? IV, this was number 3. Then in order to do number 4, now understand they wanted the term. Which term? So at this point, they are now looking for n, and they gave you the value for Tn, right? So what do? You have again that formula Tn is equals to 2n squared minus 4n plus 7, right? So in the place of Tn, we can just go ahead and substitute that 55, and then we have 2n squared minus 4n plus 7. Right. So that means at this point we are looking for n. Now take this 55, transpose it over to the side. That's 2n squared minus 4n. And then if we say 7 minus 55, that's going to give us negative 48. Right. Now at this point we can say that all these numbers are divisible by 2. So we can divide throughout by 2. So divide on the left-hand side by 2, divide also on the right-hand side by 2. Then this is n squared minus 2n, and then minus 24 is equals to 0, right? So at this point, we must factorize this. So we are looking for the factors of 24. When you multiply them together, they're going to give you 24. But then if you add or subtract them, they're going to give you 2, right? So we know the factors are 6 and 4, right? So it definitely has to be 6 and 4. So because the middle term is negative, we know that's n minus 6. So 6 will have the sign of the middle term, and then n plus 4, right, is equal to 0. So what is our values for n? N is either equals to 6 or n is equals to negative 4. But then remember what we spoke about. N must always be an element of natural numbers, right? So negative 4 here is not a natural number. So remember, when we looking for the term, we are looking for the position. We cannot say the position is negative 4. Hence, we're going to come here and say n must not be equals to negative 4. So this is not applicable. So that means the only true value here can be n is equals to 6. So I hope all that makes sense. Okay, let's proceed. Then they say determine between which two consecutive terms of the quadratic sequence the first difference will be 218, right? I mean 2018, not 218, 2018. So now it's still continuation on this question, right? So now they're looking for they're looking for the two consecutive terms of the quadratic sequence where the first difference will be equal to 2018. Now, when we are speaking of the first difference, note this. There's a reason why I told you this before we even started with the question. I said whenever we have the first difference actually represents the arithmetic sequence, right? So when they say first difference, just know that they're referring to the arithmetic sequence. Now, we want the two terms, the two consecutive terms of the quadratic sequence, whereby we will find our first difference, our arithmetic sequence being 2018. So this has to do with the arithmetic sequence. Remember, our arithmetic sequence was 2, 6, and 10. 2, 6, 10. So the difference here was 4, right? So the difference was 4, and then this is our D. Now, that means if we are to solve this question, we need to actually find the nth term for the arithmetic sequence, right? Because this question is on the first differences, and the first differences are actually the arithmetic sequence. So we need to find the nth term of the arithmetic sequence. So we have Tn is equals to A plus bracket n minus 1 and then D, right? So to find that, what is our A? The A here for the first differences is 2 and then plus bracket n minus 1. D is 4. So let's calculate here. We'll have 2 plus 4n minus 4. So this will give us 4n minus 2, right? So this will be the nth term for the arithmetic sequence, or the nth term for the first differences. Now, we want the two consecutive terms of the quadratic pattern that whereby the first differences will be equals to 2018. So we're just going to go ahead and substitute 2018, because what needs to be 2018 is the first difference. So we have 4n minus 2. If we take this negative 2 over to the side, we now have 2020, and then it's equals to 4n, right? So we have the COVID year, and then divided by 4. So n is equals to 2020 divided by 4. That's going to give us 505, right? But then this is what I want you to understand. If we have the quadratic pattern here, if we have the quadratic pattern, let's say it's A, B, C, and D, right? Now, we do understand that the first term of the first differences will be in between the first and the second term of the quadratic pattern. So let's say we have E here, we have F here, and then we have G, right? So the first term and the second term of the quadratic pattern actually embody the first term of the arithmetic pattern, right? So the first term of the arithmetic pattern is always between the first and the second. That means if we have 505 here, this is term 505 of the arithmetic sequence. That means it is in between what? It is in between the 505 term and the 506 term. So it's in between the 505th term and the 506th term, right, of the quadratic pattern. Because we can see here the first term of the arithmetic pattern is between the first and the second. The second term of the arithmetic pattern is between the second and the third term of the quadratic pattern. So that means if we find that this term here, 2018, is in term number 505, that means in respect to the quadratic sequence, it's in between term number 505 and term number 506, right? I hope all that makes sense. Now, 5 says, what is the value of the first term of the sequence that is greater than 77? What is the value of the first term of the sequence that is greater than 77? So now they're obviously asking about the quadratic pattern. So remember, we have Tn is equals to 2n squared minus 4n and then plus 7. Right. So now they're looking for the first term of the sequence that will be greater than 77. That means we can say 2n squared minus 4n plus 7 and then greater than 77. Right. So in order to calculate that, we obviously need to take this 77 over to the side. This is 2n squared minus 4n. Then what is 7 minus 77? That's negative 70 and then greater than 0. The numbers here are divisible by 2, so we can divide throughout by 2, right? So we're gonna have n squared minus 2n and then minus 35, and then that's greater than 0. So in order to factorize this, we are looking for the factors of 35. When we multiply them, they're going to give us 35. But then when we add or subtract them, they're going to give us 2. So that's definitely 7 times 5, right? So that's 7 and 5. So that's n minus 7. And then this is n plus 5. And then greater than 0. Right. But then since we are looking for greater than, we want to say our values, our critical values are negative 5 and also 7, right? So we know negative 5 cannot be part of it because once again, n must be an element of natural numbers. Negative 5 is not a natural number. So that means our value must be n greater than 7, right? So what is the value of the first term of the sequence that is greater than 77? If n has to be greater than 7, that means the first value that will have a term or that will have a value that is greater than 77 is actually 8. So that's the next integer after 7, right? So you can even prove it here. Let's substitute 8 here and see if we really gonna get a value that is greater than 77. So if we say 2, and then in the place of n, we put the 8, we say 8 square minus 4 times 8, and then plus 7, right? So this is 2 in bracket 8, and then square minus 4 times 8 plus 7, right? So this is giving us a value of 103, right? Which is greater than 77. Now, to actually prove that 8 is the first term that will be greater than 77, let's substitute 7 and see if we substitute 7, what is it that we actually get, right? Then if we substitute 7 instead, let's see. If we substitute 7, we get exactly 77. But then they're not looking for the value. They're not looking for the term which will produce a value that is equal to 77. They're looking for a term which will produce a value that is greater than 77. So a term that will produce such a value is n is equals to 8, right? So I hope that also makes sense. Okay, and then let's proceed. Okay, activity number 2 says the quadratic pattern -3 and then 4x and 30 is given. Determine the value of x, right? So this is a quadratic pattern. So let's go ahead. This would be -3, 4, and then we have x, and then we have 30. We know in order to find the difference, we need to say this is 4 minus -3. So if we say 4 minus -3, this is going to give us 7. Then this minus that, that's x minus 4. Then this minus that, that's 30 minus x. So this is our first difference. We know that it produces an arithmetic pattern. So we need this one, whereby we'll have a consistent difference. So this is x minus 4 minus 7. So this would be x. If we say minus 4 minus 7, that's minus 11. So what we did here is just to say x minus 4 minus 7, and then we got x minus 11, right? Then at this part, we need to say 30 minus x and then minus the whole of x minus 4, right? Note that I'm putting it inside the brackets because it is actually an expression, right? So that means when solving this, we're going to end up with 30 plus 4 because negative and negative is positive. So 30 plus 4, that's 34. And then negative x minus x, that's minus 2x, right? But then remember, since we know that the second difference of the quadratic pattern is constant, right? So that means we can equate these two expressions here because they represent the second difference, and the second difference is a constant. So we can say x is equals to 11, x minus 11, meant to say, is equals to 34 minus 2x, right? Then let's solve for x now. Transpose this negative 2x over to the side. This is x plus 2x, and then 34 plus 11, right? So this is giving us 3x. And then what is 34 plus 11? That will give us 45. Then if we divide both sides by 3, dividing both sides by 3, my x is now equals to 45 divided by 3. This is now equals to 15. So my value for x is 15, right? So just like that, I've calculated the value for x. So I hope that makes sense. Also, guys, take the time to pause the video and try to understand how I approach some of the questions, and also try to do them on your own, guys. Do not just watch the videos, but then watch them in a proactive manner, practicing the questions along with me. Then activity number 3 says the first 4 terms of a quadratic number pattern are -1, x, and then 3, and then x plus 8. Now it says calculate the value or the values of x. So this means that it is possible that we might find more than one value for x, right? So let's calculate. We have -1, and then this is x, and then 3, and then x plus 8, right? So in order to find the difference here, this is x minus -1, which will be x plus 1. And then here we will have 3 minus x. And then this here will be x plus 8 minus 3. So this would be x plus 5, right? If we say 8 minus 3, that's 5. Then remember, this is the first difference. So we still need the second difference because this is a quadratic number pattern, right? So to find the second difference, we need to say 3 minus x minus the whole expression x plus 1, right? And then here we need to say x plus 5 minus the whole expression 3 minus x, right? So note when I'm subtracting expressions, I put them inside the brackets. Then what is 3 minus 1? It's 2, and then -x minus x, that's -2x, right? Then here I have x, negative, it's positive. So what is x plus x? That's 2x, and then 5 minus 3, that's equals to +2. So now I have the second difference being represented by these expressions. But then remember, the second difference is constant. So that means I can go ahead and equate these two expressions, right? So at this point, what is it that I need to do? Let me take this 2 over to this side. So this would be 2 minus 2, and then take this -2 here over to that side. So I took the +2 over to the side, and then take the -2x over to that side. So this is 2x plus 2x. Now, what is it that we have here? It's 0, then is equals to 4x, right? So do not be intimidated by getting 0 here. It is possible to have your x value as 0. So 0 divided by 4 is 0. Now look at this, a confirmation that our answer is indeed correct. Look at this, number 2, if x is equals to 0. If x is equals to 0. So that means that is a confirmation. They never say if what is equals to what, and then it happens not to be that correct answer, right? So if they say if this value is equals to that, then you know that it's just a confirmation to tell you that that should be the answer from the previous question. Then let's check now. Determine the position of the first term in the quadratic number pattern for which the sum of the n first differences will be greater than 250, right? So now that we have our x is 0, so this means our quadratic pattern is -1, and then 0 here, then we have 3, 0 plus 8 is just 8, right? Then determine the position of the first term in the quadratic number pattern for which the sum of the n first differences will be greater than 250. The sum of the first n differences, right? Now, when they're talking about first differences, we know that our eyes are now on the arithmetic sequence, right? So whenever they just mention first difference, that means we don't actually care about the quadratic pattern. What we actually need to solve with is the arithmetic pattern, which is the first difference. So 0 minus that, that's +1, 3 minus 0, that's 3, and then 8 minus 3, that's 5, right? Then we have our consistent difference of 2, right? So in order to find the sum, obviously we need to first get this formula. We need to first write this formula as n is equals to n over 2, and then bracket 2a plus n minus 1, and then we have d here, right? Okay, so now they said for which the first differences will be greater than 2/5. The first differences need to be greater than 2/5. So let's solve it here. So we have n over 2, right? And then bracket, this is 2. What is my a? My a value is the first term for the first differences. So it's 1, right? So I'll substitute 1 there. And then n minus 1. Then our difference, our common difference here was 2, right? So let's substitute 2 there. Then it should be greater than what? 2/5. So we're just going to go ahead and say greater than 2/5. Now, a quick math that you need to do here, you can just get rid of this 2 here by just multiplying by 2 both sides, right? So you don't want to complicate this. You don't want to multiply a fraction inside here. Rather get rid of this 2 by just multiplying by its reciprocal. Then now we'll only be left with the n here. And then 2 times 1 is 2. And then inside here we have 2n minus 2. And then that's greater than 500, right? So greater than 500. Now let's solve. So that means inside here we're going to end up with, this is 2 minus 2. It's going to give you 0. So we have 2n inside here, then greater than 500. We say n times 2n, that's 2n squared, and then greater than 500. We can divide both sides now by 2. We divide both sides by 2. Then our n square is greater than 250. Then at this point, we can square both sides. So if we square both sides, our n must be greater than. So let's find the square root for 250. That's 5 root 10, which is something like 15.811, right? So now if we have that, remember we are looking for the first term in the quadratic number pattern for which the sum of the first n differences will be greater than 2/5, right? So for which this will be greater than 2/5. Now that we have n greater than 15.811, we know that our n should always be an element of natural numbers, which a natural number, we know that it must be an integer. Then that means our n here should be equals to 16, right? So it should be equals to 16. So that will be the first n value. That will be the first n value for the quadratic pattern. That will produce a number that is actually greater than 250 for the first differences, right? So n is equals to 16. Now, number 4 says dots are arranged to form a sequence of patterns as shown below. So we have 1 dot, and then followed by 1, 2, 3, 4, 5 dots, and then followed by 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right, dots. Then on and on and on. Now, let's just write the numbers. We have 1. We have 5, and then here we said we have 13, right? So if we check this, this obviously needs to form a quadratic pattern. They say if the pattern behaves consistently, write down the number of dots in pattern number 5, right? So all we have to do here is just find out the relationship between this. So we have 1, 5, 13, and then how many dots are here? Let's calculate. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, right? Then let's check if we are to have this quadratic pattern. That's 5 minus 1. It's going to give us 4. Then if we say 13 minus 5, that's going to give us 8. And then if we say 25 minus 13, that's going to give us 12. So we can see that we are actually forming a quadratic pattern. Look at this. The second difference is now consistent. There's a difference of 4, right? Now they're saying if the pattern behaves consistently, write down the number of dots in the fifth pattern. So this would be, we know that the second difference is consistent. So we have our 4 here. 12 plus 4, that's going to give us 16. So to find the fifth term, we need to say 25 plus 16. 25 plus 16. And then that's going to be 41. So that will be our value for pattern number 5, right? So T5 or pattern number 5 is equals to 41. And just like that. Now they're saying determine a formula for the number of dots in the nth pattern. So we already know second difference equated to 2a. First difference equated to 3a plus b. And then the value of the quadratic pattern equated to a plus b plus c, right? And then we're just going to go ahead and choose the first branch here. So let's calculate. We have 2a is equals to 4. Then to calculate the value of a, divide both sides by 2. So my a is equals to 2, right? Then to find the value of b, substitute here the value of a, that is 3 times 2, plus b is equals to 4. This will give me 6. And then b is equals to 4 minus 6. So the value for b is negative 2, right? Then let's calculate the value for c. A plus b plus c, that will be 2 plus negative 2 plus c is equals to 1. Now, 2 plus negative 2 is 0. So we have c is equals to 1, right? So the nth term for number 2 will now be Tn is equals to 2n squared minus 2n and then plus 1, right? Remember, we are writing it in the format of Tn is equals to an squared plus bn plus c. So you can see the value of a was 2, the value of b negative 2, and the value of c is positive 1. So that's how we have our nth term. Okay, yeah. Then let's check number 3. Yeah. Use your formula to calculate which pattern number has 1,985 dots. So we are required to use our formula. So our formula was Tn is equals to 2n squared minus 2n plus 1. So now we want to find out for which value of n will we have 1,985 dots. So that means this is our value for Tn. And what are we looking for? We are looking for n, right? So let's substitute 1,985 is equals to 2n squared minus 2n and then plus 1. Take this, bring it over to the side. This is 2n squared minus 2n. So this would be 1 minus 1,985. That's negative 1984. Wow. If you are now so dependent on the calculator, you even do such questions with the calculator. Then n squared minus n, that's negative 1,984 divided by 2. That's negative 992 is equals to 0. Now looking for the factors, this one is just a big number like that. So we can just go ahead and punch it in our quadratic pattern. In our quadratic formula, meant to say, quadratic formula, we know it's like that. So yeah, remember this is still in quadratic format, so you are allowed to use this, the negative 1. So, but I'm just gonna use it to get the factors, and then it would be like I factorized. So I'm getting 32, so that's n. I'm going to write it as n minus 32. So if I change the plus to a minus there, I'm getting negative 31, so I'm going to write it as n plus 31, right? So no one would be able to tell that I actually used the quadratic formula. So my n is equals to 32, or my n is equals to negative 31. But remember, n must always be an element of natural numbers, cannot be a negative, right? Then that means we come here and say n should not be equals to negative 31. So that means the only true value here is n is equals to 32, right? So in the 32nd pattern, that's where we're going to have 1985 dots. Okay, so let's look at this question 5 here. It says the following sequence of numbers forms a quadratic sequence. We have negative 3 followed by negative 2 and then negative 3 and then negative 6 and lastly negative 11. Right, so let's find the first difference here. If we say negative 2 minus negative 3, that's positive 1. Then if we say negative 3 minus negative 2, that's negative 1. And then here, negative 6 minus negative 3, that's negative 3. Then negative 11 minus negative 6, that's negative 5, right? Then this would be negative 1 minus 1, that's negative 2. Negative 3 minus negative 1, also negative 2. And then negative 5 minus negative 3, obviously negative 2, because remember we have our second difference always being constant, right? Okay, now they say the first differences of the above sequence also forms a sequence. Now, what type of sequence is formed by the first differences of the quadratic sequence? We already know that the first differences of the quadratic sequence always forms the arithmetic sequence, right? So put that in the back of your mind. The first differences of a quadratic sequence forms the arithmetic sequence. Now they say determine an expression for the general term of the first differences, right? Now note, we are not here trying to calculate the n term of the quadratic sequence. We are trying to calculate the n term of the arithmetic sequence because we are trying to express, to have an expression for the general term of the first differences, which the first differences happen to be the arithmetic sequence. So this is Tn is equals to A plus n minus 1, and then we have D. What is our A? Note, the A that we are going to use is not for this one. Remember, this one is the quadratic sequence. We are looking for the arithmetic sequence. So our A is 1, and then plus n minus 1. And then what is D? It's negative 2, right? So this is 1, and then negative 2n, and then negative 1 times negative 2, that's plus 2. So our Tn is equals to negative 2n and then plus 3, right? So that's the expression for the general term of the first differences, right? That's how we were supposed to do it. Then B says calculate the first difference between the 35th and the 36th terms of the quadratic pattern. When it comes to maths, you have to ask yourself, why is it that they're asking me this question after I just determined the expression of the general term of the first differences? That means there is a relationship with the mathematics. The questions that follow after a question, we call them follow-up questions, right? So they always relate to the question that you answered above, right? So now let's look at this. Let's observe something here. Suppose that I want to find, or I want to locate the first term of my first difference. I would locate it in between the first and the second term of the quadratic pattern. And suppose that I want to locate the second term of my first difference. I would locate it in between the second and the third term of the quadratic pattern, and so on and so on. If I'm looking for the third term of the arithmetic pattern of first difference, that's in between the third and the fourth of the quadratic pattern, which means what they're looking for here, the first difference between the 35th and the 36th term of the quadratic pattern. This would be located, the first difference is located between the 35th and the 36th term, which then represents T35 of the arithmetic pattern. As we can see here, this represents T1 of the arithmetic pattern, but it's in between T1 and T2 of quadratic. This represents T2 of arithmetic pattern, but it's in between T2 and T3 of quadratic. So the first difference we are looking for is T35, which is in between the 35th and the 36th term of the quadratic pattern. So that's what you needed to observe here. So you say T35 is equals to -2, and you just use this and substitute 35, right? We are not substituting 36 because a term that is in between the 35th and the 36th term of the quadratic pattern is the 35th term of the arithmetic pattern, right? So we just go ahead and say -2 bracket 35 and then plus 3, right? So this is -67, right? And that's how you would have solved that question. Now, look at C. This is when they're saying determine an expression for the n term of the quadratic sequence, right? So let's go to C. Okay. Now, to determine the n term of the quadratic sequence, we know that we have to equate the second difference to 2a, then equate the first difference to 3a plus b, then equate the terms of the quadratic sequence to a plus b plus c, right? Then we go ahead and just select the first branch here, right? Select the first branch. This is going to be 2a is equals to -2. Then if we divide both sides by 2, then our a is equals to -1, right? So to calculate the value of b, I just substitute a there, then that's -1 plus b equated to the value there, which is 1. And then what is 3 times -1? That's -3. So this is b is equals to 1. If I transpose it over to this side, it's going to be positive. So 1 plus 3. So this is b is equals to 4. Now to look for the value of c, this is a plus, okay, let me just substitute right away. Then my a value is -1 and then plus 4. So note I'm substituting here now. Then plus c is equals to -3. -1 plus 4 is +3. If I transpose it over to that side, it's -3 minus 3, right? Then c is equals to -6. That means my Tn will now be equals to -n squared plus 4n and then minus 6, right? So this would be my nth term for the quadratic sequence, just like that. Now, D says, explain why the sequence will never contain a positive term. Okay, let's clear the screen for that. So we have Tn is equals to -n squared plus 4n minus 6. Note with these questions, no calculation is required whatsoever. All you need to do is explain the relationship of numbers here. So what are we going to do? Let's just say Tn. So usually these questions are about 3 marks, right? Just for you to explain. Then this is Tn is equals to -n squared. Then I will say Tn will always be less than 0 for n element of real numbers. What does this mean? It means that whatever I choose to substitute for n, whatever value whatever integer or value I choose to substitute for n, it will always come out, this whole expression here will always come out as negative, right? So look at this. We have negative outside, and then here, whatever number that we choose to substitute here, this will always come out as a positive. But because of this negative here, we're going to end up having it as negative. Remember, any number, whether negative or positive, if you square it, it comes out as a positive. But because of this negative outside here, then that number will eventually become a negative. So we say Tn will be less than 0 for n element of real numbers, right? This is the first part. Now let's take this term and that term, right? So -n squared plus 4n. Now we are saying for -n squared plus 4n, your Tn will only be greater than 0 for this values here. For n element of 0 all the way up until 4. So if you substitute any number that is in between 0 to 4, that means if you substitute 1, 2, or 3, you will have a value that is greater than 0. So you can even try it here. Let's say we are substituting 1. We say 1 square plus 4 times 1. This is going to give us 3, right? If we say 2 square plus 4 times 2, and then let's punch it, that's negative 2 square plus 4 times 2. This is giving us 4, right? And then if we are substituting 3, this is 3 squared plus 4 times 3. So let's substitute 3 there. This is going to give us 3, right? Now, but then look at this. All the values, obviously, if you substitute 0 and 4, it's just going to give us 0. Look at all these values that we are having here. All these values are below 6, right? They're not greater than 6, which means even if we find a positive value from this part here, the fact that the positive value that we find is not greater than 6, that means if we have to subtract 6 from it, we're going to end up having a negative anyways. So we're going to say but negative n squared plus 4n is less than positive 6, right? So if this whole expression here is giving us values that are less than 6, that means if we say 3 minus 6, that's a negative value, negative 3. 4 minus 6, that's negative 2, a negative value again. 3 minus 6, that's negative 3, right? So because this expression fails to give us a value that will be greater than 6 here, that means the whole expression Tn is equals to negative n squared plus 4n minus 6 will never have a positive term. So we say negative n squared plus 4n minus 6, Tn will always be less than 0 for all n element of real numbers. See that? So can you say that I did not involve any calculation besides just to try to make you see the solutions here? But then this does not involve any calculation. It's just you explaining to us that you understand that this will always produce a negative value, and then this will always produce a negative value, but will produce positive values only when your n is an element of 0 up until 4. But then still, those values that are produced from this values that are substituted here are not greater than 6. So for the reason that they're not greater than 6, that means that this expression here will fail to give us a positive value, because if we have a smaller number here, then if we subtract minus 60, if we subtract 6 here, then it's going to end up giving us a negative value. So therefore Tn is less than 0 for all n element of real numbers. So that's how you explain this, guys. I know these questions are a little bit tricky because now you are used to all calculations, but then now when you have to explain, it's a little bit of a challenge. So try to practice this kind of questions, especially if you're out there aiming for a level 7 or you want to achieve those 90%, 100%. These are the questions that you need to really master, right? Okay, so with all that being said, thank you guys for watching the lesson, and then please hit that thumbs up button if you enjoyed the lesson. If you are watching and you haven't subscribed, what are you waiting for, man? Please subscribe to the channel, and then also share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are working as a team and we are winning as a team.